Mathematics 2 Chapter Integration. Tutorial question 12 A and B. Let's start by doing A. They give you the dy over dx, where it mentioned x cannot be equal to 0, as well as they give you information when y equals to 0, x equals to 1. Now, find the expression of y in terms of x. How to find the expression of y given your derivative? Now, let's always remember the reversing technique. How does it goes? If let's say you have a function of y in terms of x, if you differentiate it, you perform a differentiation, you will always get the derivative dy over dx, or you can also say f prime x is the same thing. So if let's say you reverse this technique, meaning you're going to integrate your derivative. If you integrate your derivative, then you obtain back the expression of y. So this is what we're going to do. We're going to integrate the derivative given. Now, let's do it one by one. You notice that I have expression 2x minus 3 over x squared. Now you notice your x squared is at the denominator. So it's very difficult for you to integrate directly. So what we do first is we bring the power up. So if we bring the power up, the power will change from positive to become negative. So I did not do any integration. I just rearrange my expression. And now I can do an integration. Now how is the integration for polynomial? Is very simple. The power will be added up by 1 and you divide by that power. So the outcome will be 2x. Initially with the power of 1, when you integrate it become 1 plus 1 become 2. Then you divide by that power 2. Same goes here. Initially, you have x to the power of negative 2. So negative 2 plus 1 become? Yes, correct, negative 1. Divide by negative 1, which is the power itself. Remember, this is indefinite integral. You always need to put c at the end, which is your arbitrary constant. You notice or not? The 2 and 2 can be simplified. That's why I only obtain x squared. Now, in the case of here, minus and minus, what happened? It will be your positive value. Now, since I have 3x to the power of negative 1, basically I can bring back our x to the power of negative 1 to become a denominator, so that our power become positive power. So these two is the same thing. However, they told you to find expression of y in terms of x. You notice or not, it's not completely in terms of x. It's still having a c. So I need to complete my expression of y. Now, how do I do that? Look at into the second information. They give you a condition, or what we call initial value. So when y equals to 0, x equals to 1. I'm going to substitute that information into the y equation that I obtain after I integrate. So here, my y is equal to 0. Meanwhile, my x will become 1. At the end of the day, I can solve for the value of c. Then I will obtain a complete equation of y in terms of x only, which is y equivalent to x squared plus 3 over x minus 4. Now, we have complete A. How about B? Show that for all non-zero value of x, x squared d to y dx squared minus 2y equivalents to k, where k is a constant to be found. Alright, there is a various method on how to do it. I'm going to give you a very simple method, which is you just simply need to form the equation of left hand side, then you can obtain the value of k. Now, from the A, we know our y is equivalent to x squared plus 3 over x minus 4. We differentiate our y, we'll obtain dy over dx. Now, differentiating is slightly different from integration. Please remember, the 2 will go in front, so 2x. Meanwhile, the power will reduce by 1. So that's why you only obtain 2x. Same goes here. So initially, 3 over x, if you rearrange it, it can be written as 3x to the power of negative 1, yeah, negative 1. So bring the negative 1 in front, meaning negative 1 times 3 become minus 3x. Then the power will reduce by 1. Negative 1 minus 1 become negative 2. How about negative 4? If you differentiate a constant, it will become correct 0. So this is our dy over dx. What happened if I differentiate once again? I will obtain the second derivative. Now differentiate 2x. You will only obtain 2. Differentiate 3x negative 2. Now the negative 2 will bring in front. So negative 2 times negative 3 is positive 6. Now the power of x will reduce by 1. So negative 2 minus 1 will become negative 3. So this is my second derivative. Now let's look into the left hand side. Left hand side is x square d2y dx square minus 2y. Let's try to substitute in all this information. Now we know we have x square. We also obtain our second derivative, which is 2 plus 6x to the power of negative 3. And then minus with 2y. What is our y just now? We obtain x square plus 3x negative 1 minus 4. Now this is our left hand side. Now expand 1 by 1, you will got 2x squared. Now x squared times 6x power of negative 3. What happened here? Correct, it will only become 6x power of negative 1. Same goes here. You will got negative 2x squared. Now negative 2 times 3 become negative 6x to the power of negative 1. Last but not least, negative 2 times negative 4 will become positive 8. Now simplify it. 2x squared minus 2x squared gone. Positive 6x to the power of negative 1 minus 6x to the power of negative 1 gone. So basically, left hand side is just simply 8. Now, look at here. Your right hand side is k. So in the case of here, left hand side equals to right hand side, hence k equals to 8. There is another way for you to find the value of k without substituting all of these. Now, additional information, second method. Let me clear all of these. Initially, you have obtained your second derivative, correct? Now, in the second derivative, in front of it, there is x squared. So, why not you multiply your second derivative with x squared? So, what happened here? You will obtain x squared d2y dx squared. If you multiply one side with x squared, the other side also you have to multiply. Notice or not, if you multiply 1 by 1, you will obtain 2x squared plus 6x to the power of negative 1. Now, if let's say I try to rearrange this information, I have x squared d2y dx squared equivalent to 2. Now, since 2 and 6 both are a factor of 2, I'm going to factorize 2 outside. I will got x squared plus 3x to the power of negative 1. Can you notice or not something? What is this? X squared plus 3x to the power of 1. X squared plus 3x to the power of negative 1 is almost the same thing. What is this? This is our y. However, our y here has negative 4. Our expression here do not have. So what I do is I'm going to change my expression inside the bracket. So I'm going to put in the negative 4 inside here. If I put in negative 4, I have changed the original expression, correct? Because 2 times negative 4 is negative 8, which this expression don't have negative 8 at the right hand side. So what I do is I'm going to plus with 8 again. Why? It's a cancellation technique. You see, 2 times negative 4 is negative 8. But if I plus back with 8, so basically it's our original function, meaning I have not changed the original, I just reform the expression. Why I do so? So that I can replace everything inside the bracket. The same thing as my y expression. Now I can replace it as, yes, correct, 2y, because everything inside the bracket is your y expression, plus with 8. So at the end of the day, if I bring my 2y to the other side, you notice or not? Yes, correct. You got exactly expression as the given question. See, x squared, second derivative minus 2y equivalence to k. Hence, you can say k equals to 8. So you may choose method 1 and method 2. The final answer should be the same. That's all.